Hello, in this video I'm going to try to show you how to create a small scale digital elevation model. Specifically, we're going to create a 1 to 250,000 scale DEM model for the sample area that I'm using by way of example, which is the Gila Wilderness area in southwestern New Mexico. And I've got sort of the finished product here on the screen so you can see where we're going. You can see in red the outline of my wilderness area. From a previous exercise, you can see the 7.5 minute 1 to 24,000 scale quad index that we created. And at a larger reference here in the red is the 1 to 250,000 scale quad index, which you also have available in the data set that you downloaded from a previous exercise. And if not, then look for the topo indices data set on our class site. Now, the reason you might want to go with a 1 to 250,000 scale is because I was able to actually create this entire DEM model that you see here with one download, one file, and the compressed file size was less than 2 megs in size. So, and you end up, as you can see, with a pretty neat product. I'm sorry. Let me zoom in to the boundary so you can see the detail a little bit. And granted, if you zoomed in very close, it's going to get pretty fuzzy. Okay, so you can see, as you can see here, but realize that you're dealing with large acreages, and it's important that you. I'm going to zoom back out to the extent of the boundary. It's important that you sort of develop an appreciation for scale and size in your file sizes that you're working with. And as you probably no doubt encountered already, your file sizes can grow exponentially when you start working with data with large areas. So I'm going to try to keep some of my examples small in terms of file size, and that's the reason I'm using this 1 to 250,000 scale. Now, if I were interested in a DEM for a specific quad within this 7.5 minute quad, like say this mountainous area here, the white is more mountainous and the green is the lower areas by way of reference here. And it's kind of interesting because you can see, as a side note, you can see all of the little drainages that are within this area very nicely in this DEM. But you know, if I were interested in one or two of the quads within this area, then I might opt to download the DEM data at a 7.5 minute or the 1 to 24,000 scale resolution. But for way of reference, I wanted a nice DEM for my entire area. So instead of downloading all of these individual 7.5 minute quads and then having to deal with trying to mosaic them together and things like that, I was able to get all of my area here in one 250,000 scale quad. So there are a lot of other issues that come up, a lot of other things you might want to do. You might want to try to clip this. Or you might want to go the route of getting the 1 to 7.5 minutes and mosaicing them together. Those are all sort of separate issues that we won't deal with here today for sake of time. I just wanted to at least get you started by showing you how you can start getting some elevation data for your area. So you won't find any of this in a book anywhere, and it's very hard actually to even find the DEM data anymore. Used to be this was the most common elevation data set and the only elevation data set you could get at one time, and now it's sort of the other extreme. This has been or is being replaced over time with what we call NED data, National Elevation Data Set data. And there's nothing per se really wrong or right with any of these data sets. I'm a little biased towards the DEM data, I guess, because I'm a little old-fashioned. I've been doing this a long time, and this was the data that I started out with. But also, and again, this may be a personal bias, but it seems to me like the quality of this data is a bit better than the NED data in terms of the visual aspects. Again, I may be wrong about that, but that's just, it seems to me, I like the quality of the data better when I look at it. So, excuse me. So this is what we're going to use for our example today, and this is where you're going to end up when we're finished with this exercise. So let's start at the beginning. Let me close this. Oh, one other thing I wanted to show you. Let me zoom back out just a little bit. Again, you can see the 7.5 minute quads here, and just again to show you how this can grow exponentially. You see we were basically able to cover with this one DEM here the equivalent of double the 7.5 minute quads that we had identified for our study area in this example. And also by way of reference, you can see out here this entire block, if I click on it with the information tool, this entire block is one 250,000 scale quad. Now the data that I'm going to show you, even though it's 250,000 scale data, it's split into two different files. There's an east version and a west version. So what you'll want to do for your study area is load your boundary that you've hopefully already created. And if you want to load your 7.5 minute indices, that's fine. And then you'll want to identify which quad you'll need for your area by turning on the 250,000 scale quads and the quad index, I'm sorry, and locating your area within that, and you'll be able to, hopefully you'll be able to get it in one. Sometimes you may have to get two. It just depends. I was lucky here because mine just happened to be in the very southwest corner of this quad, which is pretty rare. A lot of times it will cross over more than one, but hopefully you'll get yours in one. If not, then you'll need to identify all of the quads that you'll need to download. So let's go ahead. Let me switch over to actually, like I said, I think what I'll do, I'll separate this by the data source itself. I was going to show you where I downloaded the data. Let me just show you this one page, but we'll focus most of our data sources in a separate video for the sake of time. But just because I know some of you will want to go ahead and get started with this right away, I'm going to go ahead and pull this screen over, working off of two monitors here, so bear with me. I have to kind of swap screens to get it in the video. So let me back up a little bit here. I've got it set to the screen where I downloaded my data from. So let's back up a couple. Okay, now if you'll bookmark or write down this path right here, we'll worry about the source details later. I'll give you some information about some of the sources, but just suffice it to say, it's pretty tough to find these DEM models anymore because of the predominance of the NED data that's coming out now. But I was able to dig around and find this site, and you'll want to save this because you probably won't find this site anywhere. So write down this path here, and you can see it's a USGS site. Anyway, write down this site path, and what this is an index of all the 1 to 250,000 scale DEM models for the entire country. So they're all arranged alphabetically within these folders, and in my case I've identified that the one that I want is Clifton. Okay, each just like with the 7.5 minute scales, the topos all have unique names, but they're not always unique. There can be well, they are unique for all intents and purposes. Just for this case, they're all unique. We'll put it that way. So from the index, I identified I need Clifton, and so I'll go under the C's here, and here are a list again of all of any of the 250,000 scales that begin with a C across the country. So as you look through, some of these names will jump out at you if you're familiar with the different regions of the country, like Chalice, I believe, would be in Idaho. Carlsbad's probably in New Mexico. Cape Fear's probably over on the coast off North Carolina. Just going by some of these names, Charlotte. There's Chattanooga coming in down there. Interesting. So anyway, we're looking for Clifton. So let's scroll down here, and you can see the first time I did this I accidentally got Clinton, which is easy to do, but it gives us a good cleaning example for later, so we can do a little demonstration on cleaning up your data. But what I did in this case is I was able to tell, let me minimize this again, I was able to tell, of course, that I needed the eastern half. Okay, mine's specifically in the southeastern half, but I have to go with east or west, so I've got the eastern version of that file. And what you want to do, you can right click on this file and go to Save Link As, and depending on if you're running Internet Explorer or Firefox, it may save a little differently. Notice that Firefox tends to want to save to the downloads folder a lot of times, and usually I like to route it to whichever folder I want to put it in. So if I right click, sometimes it will give me more options. And in this case, I've already went down into my project through the GIS data, went into base data, went to raster. I'm using the same folders as we did in an earlier exercise for consistency. And I created a new folder called DEM 250. Okay, if I back up one, you can see these are the raster folders that I have thus far. And so I went into the DEM 250 and saved that file here. Okay, and just takes it a few minutes to download, not very long at all because it's not that large. And let me minimize this, and let me go ahead and I'm going to start a new project, so we can set this to blank, say OK, and yeah, we'll save our changes just in case I forgot to save before I did this. And we'll have us a new project here. Okay, you can see we're down here with the unknown units. It's set to no coordinate system is defined or anything. We've got a blank slate there. Now we want to do something to that file we downloaded before we proceed. So what you'll want to do is you'll want to unzip that file. If you're using WinZip or 7-zip, I believe works the same way. You can just right click and go to the little unzip, in this case WinZip, and I wanted to extract it to here, which I've already done, so I won't do it again. But once you do that, it will download or it will unzip. Now let me actually delete this and unzip it again, because I want you to see something that will happen. And there's two different, let me unzip my or delete my DEMs first. I want to show you a couple things that you might run into. When I had accidentally downloaded the Clinton by mistake, when I unzip that file, I go to WinZip and extract to here, and it just extracted it. Let's see, hang on here. It's wanting to replace a file, so I must not have deleted everything. Let me drag it over here where you can see what I'm seeing here. Let's say no. I think, let me find the file here. Well, I'm not sure which one it is. So what I'm going to do just for this example, I'm going to move these into a temporary folder. Now understand, I'm trying to recreate a scenario here for you so you can see what will happen when you unzip, because you could get one of two options. That's why I wanted to do this. So let me go ahead here now in this temp folder. I'm going to unzip this Clinton and say unzip to here, and okay, notice it just unzipped. Okay, but it gave me a file here that unzipped. It's about 10 megs in size, and notice there's no extension with that. Okay, now I'm going to want an extension with this, and so if you get this, there's two ways these might unzip. If you get this example where it unzips into a file with no extension, didn't prompt me for anything, it just unzipped the file, go ahead and single click on that and tack on at the end of that a .dem. Okay, now my system didn't give me a warning. Depending on your system, you might get a warning about adding this extension or changing it. If it does, just say OK and go ahead and let it do it. Basically, we want to give that file a DEM extension. That's one of the things, and this only occurs with the 250,000 scale quads as far as I know. But you want to make sure you have a .dem extension. Now on my corrected file, let me delete these two since we really didn't need those. On my correct version of the file that I downloaded, when I unzipped it, it actually prompted me. Let me unzip it, and my prompt's on the other screen, so I'm going to drag it over. It prompted me to please enter the full name of the file contained within this archive. And so what I did here, it already put the dot in there. I just typed in DEM. And I think what happened here, let me say OK, and you can see it already tapped the DEM on for me, and it's also about just under 10 meg. I like to notice the file sizes as I'm manipulating files and extracting and so forth. Sometimes that gives you a clue. If this file had been really tiny for some reason, I would know something was wrong. But at least it's consistent with the previous file, and just from past experience I know that's about the correct size for these files. But I'm guessing what might have happened is when the USGS originally created these files, which as you can see on this file, when it unzipped, it's 1994. So it's been quite a while ago when they originally created these. They probably, somebody got a little sloppy apparently with the naming and maybe forgot to tack on an extension in a case or two. And so that's what you'll run into sometimes, especially on older data. Not knocking the data because the quality is excellent, but somewhere somebody got a little sloppy with the naming, and that's why the other one didn't have the DEM on it. So you may run into that, and I wanted to make you aware of that. And if it unzips without the extension, doesn't prompt you or anything, go in and add the extension. If it asks you for an extension, tack on .dem. And just be careful that you don't end up with a file, however you do this, that has more than one extension on it. And you might run into that in some cases. So just make sure you end up with this .dem extension on your file. And the little icon is plain here because it doesn't really know what a DEM, or system doesn't know what a DEM file is yet, so it doesn't put any kind of graphics with it. But that's what you want to end up with. So let me back out of this. Let me delete my temp folder. And so once you've extracted it, you end up with a DEM file again. And in my case, I had deleted it a minute ago when I was trying to show you this. So let me pause it a minute and recreate it. Okay, we're back, and I've got my DEM file here. So I'm going to go ahead and minimize the folder. And we've got a blank project started here. So let's go ahead, before we add anything to this, let me give you some more information. You're going to run into this, and I apologize, it's just a fact of life with GIS, but you're going to have to deal with projections, and some data has different projections. A lot of the current data that you download and that you find now is already in, usually in a geographic projection, which, remember, geographic is really a coordinate system rather than a projection, but you'll hear it referred to a lot of times as a projection. So a lot of times you'll be in geographic, a lot of times it'll be NAD 83, and that tends to be the most common, and there's nothing wrong with that. It's excellent. It's the newer projection. But what you're going to run into is a lot of your data sources, especially older data sources, were created in a UTM projection with the datum of 1927. Now, the fact that it's UTM is not an issue. I can mix data from different coordinate systems and projections as long as my datum is the same. As long as I've defined those data projections using the define projection tool, which we've mentioned elsewhere, and that's another whole separate topic on projections. That's a lot of this is a 101 class material, but you should find some information on our website that talks about that. But the DEM data, and I mention all this here because a lot of your DEM data is in a 1927 datum, and that can be an issue because 1927 datum data mixed with 1983 datum data is can have a little bit of a shift in it when you are actually working with it. Even if you've defined both projections, which you have to do that, if you define the projections, sometimes you'll notice a little shift. In this case, it's very subtle at the scale we're working with, and so I'm going to proceed with this as if that's not an issue, okay? And I want you're going to see some of these warning boxes are going to pop up, and I don't want you to ignore them. That's why I'm mentioning all this, because it's actually very important, because when you're dealing with areas at very close-up level of detail, that little shift can be significant. In our case, it's not going to be, and I can always go back and fix my, I can always reproject my DEM model at a later stage, and maybe we'll do that in another exercise just so you can see how to do that and make sure your data does line up just perfectly. But for the sake of time, we're going to proceed with this, knowing that this can be a little issue behind the scenes here. So you'll see what I mean as we proceed. So let's go ahead, and what we want to do in this case, because the data, we're going to pull in some of the data we worked with before, and it's already in the, it's already been created in the 1983 datum. And so if I pull that in now, then it's going to set my my data frame is going to default to that projection. I want to work with a file here in a minute that I know is in UTM 1927, and that's just with the DEM data. Nearly all of the original source DEM data is in UTM in 1927 datums. So since I know that, I'm going to go ahead and define a projection for my data frame here, and realize this is just assigned to the data frame. Doesn't affect the data that I'm going to load, that I'm about to load, but what it will do is make sure that any data that comes in is on the fly reprojected into a UTM 1927 coordinate system. As long as I've defined my data, okay, which we've done in earlier exercises with the data that we're going to use, it was defined in whatever projection it exists in. As long as it's defined, it will on the fly reproject. Now with my DEM data, in the root files of this raw data, it's defined, and when we run the little utility that you'll see in a minute in here, it will sort of the program will know that it's UTM 1927, and it will set that projection accordingly for us. That's for the DEM data. I apologize for the confusion here, but I want to explain some of this before we jump into it, and then I'll try to re-explain it as we go through it. So let's go ahead and set our projection here for this data frame. I'm going to right click on layers, go to properties, and I don't have a projection defined, so there's nothing to clear. If it was in something else, I would clear that. I want to go to predefined. I want to go to projected, not geographic this time, but projected. I want to go into UTM, and I want to go to NAD 1927. And again, you'll only see this 1927 probably with DEM data anymore. It used to be a lot more common, but with the DEM data, you'll run into it a lot. And in my particular area, I know I'm in zone 12 for New Mexico, and you'll have to figure out your zone, your UTM zone for your area. Hopefully you've got that information. If not, we'll look for that elsewhere. There are graphics out there, and in your books you might find a graphic that helps you determine the zone. In my case, I know it's zone 12, so I'm going to go ahead and I'm going to apply that. Say OK. And notice my coordinate system down here changed. It changed into meters because meters is the unit that's defined with that UTM system. And my coordinate references have changed here. So now let's go ahead and pull in some of the data that we created in an earlier exercise. Since I'm already at the quad index folder, I'm going to go ahead and pull in my new topo quad indices for the 250,000 scale. When I add this, you're going to see the first warning that I mentioned, and it's letting me know that the data that I'm loading is in a it's in a 1983 reference system, and it's seeing this because I had defined it as my datum being 1927 for this, and I'm pulling in a data source that's 1983. It's basically giving this warning. Now, one thing you don't want to do is you don't want to say, "Don't warn me about this ever again," because it's important to know when this happens. Normally, this would be a red flag. In this case, at the scale, like I mentioned earlier, we're working with, I'm going to go ahead and accept this, but it's important to know this, and you'll see this pop up again if you try to edit any of the data in this particular project we're creating or anything like that. And it's because basically the system sees a problem out there. For now, we're going to go ahead and say close, which will allow the data set to load. And then I'm going to go ahead and load the Gila boundary data that we created in an earlier exercise. So let's move into I'm in the base data folder, and I'll remember I moved that into my own mark folder before. So I'm going to go into there, go to vector, and here's my Gila boundary, and there are the quads. And just for reference, let's just get both of those. We'll add those. Again, we get that warning because those are in the 1983 data. Again, we're going to say OK this time, basically, by closing it. There's not really an OK button. We don't want to transform that. If you notice, by the way, there was a transform button. I don't recommend using that transform button. If you're going to, if you need it in a different datum, I always recommend doing a reprojection out separately in Art Catalog. But for this example, we're going to proceed with it the way it is. So let's zoom in to the extent of the Gila quads. So we can zoom in to our particular area, and now let's clean this up just a little bit. Let's move our 250,000 scales to the top. Let's set that to clear. This is up to you, your preferences here. I'm just trying to get something that will let us see the different data layers at the same time and kind of clean it up a little bit. Setting my width to 1 and the outline to a red color for the 1 to 250,000 scale index. And I'm going to go ahead and set my Gila boundary to clear as well. I'm just going to set it to a red color as well for the outline. And for the quad indices that I have, I'm going to set those to clear and just leave them in black. Set the width up to 1 or something so they show up. And let me zoom back out a little bit. Let's zoom out to this, about the size of this 1 to 250,000 scale. Sorry, it's early. Index. So you can see that as a reference. So there you go. You can see the beginnings of what we started with earlier that I showed you. You can see the reference frame anyways. And let's go ahead and save our work to this point. We don't want to lose anything by mistake. I've already created a Gila DEM. I'll just create a Gila DEM2 here for this example. And there we go. And now let's go ahead and load the, let's start our conversion. We've set earlier, we set our DEM, we made sure it had a DEM extension. And what you want to do is, you don't load this the way you would load a normal data set. Now this is one thing different with the NED data that I mentioned earlier. That's one nice thing about it. It's already created in a format that ArcMap can just pull it in as if it were another data layer. With the DEM, we actually have to perform a conversion on that file. And so since this is a database involved class, I like to cover a lot of conversions when I can, because I think it's important as part of learning to work with data sets and data management that you are armed with some tools that let you do conversions. So that's another reason I like to use the DEM data in its raw form in this class. So let's go ahead and open our toolbox. Okay, open our toolbox, and mine loads quickly because I've loaded it earlier before I created this video. Give yours a minute to load, and then expand I'm gonna close data management, and we want conversion tools. And then we want to go down to the raster set of tools under conversion, and we're interested in this DEM to raster tool. Okay, so go ahead and double click on that, and with this dialog, if you don't have the help open, it's nice to open it here just as a way of reference. You can see some further explanations of these steps. But we want to load the DEM file first, so let's open that and make sure that you route it over to the folder where you saved your data. And in my case, I put it in base data under raster, under DEM 250, and we're interested in this Clifton East DEM. So we'll say open, And by default, the output routes to a folder that 99 out of 100 times you don't want it to go to. It's putting it into basically like my documents. We want to route that back to our project folder. So let's do that by opening the folder there. And in my case, since I had already done it, it remembered that folder. So it's got it there for me. And what you'll want to do then is so route it to that folder. I'm going to save it back into the DEM 250. And actually in this case I really don't want to do that, do I? Because I'm creating this data set from an existing data. So you can see in my example here that that's where I put it, and I put it under base data. And that's fine. In your case, if you want to do that, that's fine, and that's what I had done earlier. But because I've already created it to avoid repetition here, and it might even be better suited, I'm going to go ahead and route it to the mark folder and under the raster subfolder there, and we'll just put it there. And here's where you get into some naming issues. You don't want to give this, you know, all along I've been mentioning that it's important to use 8 to 10 characters or less. Usually it's 10, I think, is the maximum. I always tell people 8 just to be safe. But the reason I've been saying that all semester is actually because of this issue here. In the DEM files, it will show up if you get spaces in your name or too long of a name, the process won't work correctly. And it doesn't really tell you why. It'll just basically crash or act like it proceeded and you won't get any results. So this is where it's very, very important to not have any spaces. And I think you can go up to 10 characters. I'm going to try to keep it to 8 to be safe. So I know it was a Clifton. And it was the east side, but I'm not going to need the west in this example. So I'm just going to go ahead and call it Cliff DEM. Cliff DEM. CLIF DEM. That key, I think that's 7, but we'll go with that for now. The important thing, try to keep it 8 or less to be safe, and everything should be fine. So we'll call it Cliff DEM, and I'll say save. And you can see the path here is where it routed it to. And now the next option here for float, for the output data type, is set to float, and that's fine to leave it float. I like to set it to integer, which is the other option. And if you click in that box over on the right hand side, we'll let you know, and the options here. And set it to integer in your case for now. And because integer will come into it, will be a lot more valuable later. Basically, you'll end up with a data set that you can actually open in your data tables if you use integer. If you use float, it's kind of like using the example on the test. You remember I had continuous and discrete data. It creates a more, although in this case it would both be continuous, it's more of a continuous data set if you create float, because it basically has outputs with decimal points after them. And so every raster in this model that gets created, which can contain millions of cells, every one will be unique if you go with float. In theory, that could give you a smoother look to your surface, but in practical, for practicalness, it gives you a very large data set that you cannot open the table to. By default, ArcMap will not let you open the table on a float type data set. And in our case, later for some other examples, we might want to look at that table. So that's why I'm setting it to integer. And also just out of necessity, but also just for being practical, you're not going to notice between float and integer, you're not going to likely notice any transition in the smoothness, visually at least, not at the scale we're looking at it anyway. So in our case here, there's a lot more usefulness to go with integer than float. So it's a long explanation, but there's times when you might want to use both. The Z factor, we're going to leave it to 1. If this were in an area that's a real flat part of the country where it's very level terrain, you might want to bump that up just a little bit to exaggerate the surface a little bit. In our case, we've got plenty. In most of your cases, you've got plenty of elevation, so just leave it set to 1 as the default. And I'm going to say OK. And you'll notice at the bottom of the screen, it all happened very quickly in my case. And yours, the first time, this may take 2 or 3 minutes to run. But you'll see at the bottom of the screen, the little blue scrolling there will tell you it's processing. And then there'll be a little dialog pop up. On mine, it's on my other monitor, and I can't seem to force it to come over to this monitor. But on the lower right corner, you'll see a little pop-up that lets you know when it's finished. Bottom line being, the first time you do this, it's going to take a lot longer than mine did just now. So just be patient, let it run till it finishes, and then you'll get automatically, it will pop up your DEM model for you. So I can close my toolbox for now. And by the way, I was going to say, by the way, if you haven't already opened Spatial Analyst, go ahead and do that. You'll want Spatial Analyst open for later parts of this exercise. So we've got our DEM model. It loaded correctly for us. Again, it's a 1927 datum, and if you zoom in very closely, you might see a little overlap because of the models here, because of the projections. But very, very little, hardly any. I'm looking at the top here and I see hardly any. This used to be a lot more pronounced in earlier versions of ArcView software, especially. If you had 2 different datums, it was really noticeable. It's become a lot less noticeable now, almost to the point to where it's not an issue. But it is, because you get that warning dialog that will pop up continuously when you've got these different datums. So ultimately, we would want to reproject this into 1983 because of that. But for this case, we're going to keep going. We've got it loaded here. You can see it loaded in the east half. This is an actual raw DEM model here. It's using the default colors. You can see over here on our layer that the low and the high is integers. And these are in meters. Like most of your DEM data is in meters. Every now and then you'll get a quad that's in feet. And again, it doesn't really tell you that anywhere. You just have to look at the numbers and apply some logic to it. We know, in my case, from looking at topo maps, I know that the elevation range is a lot higher than 3,300 feet in this area. It's more like 11,000 something feet. And so I can tell from that information that I know this is in meters and not feet. I can open the table with this, which, as I mentioned earlier, you could not do if you had used float. In this case, I can, and I can see that I only have 1,947 different records. So there are that many different whole number elevation points in this, which is nice because it's not that large. That's a lot of my point with using the DEM as an example, is that your data set is a lot more compact. Your file sizes are smaller, and all of those are important considerations when you're talking about dealing with large areas, especially where you might need multiple layers of this information. So I could do a lot of things with this, and we'll do that in some other exercises. I just wanted you to see that this is basically giving me a listing of how many individual observations, and it's actually as a count field. So I can see that I have, for example, 4 points in this model that are at 1,314 feet, 1,314 meters elevation. That is exactly that elevation, only 4 points, which is seems kind of small, but that's what that's telling me. So let me go ahead and let me clear that selection. So what do we want to do next? One of the things that you usually like to do with DEM models, and a lot of your reason for creating a DEM model, at least initially, is the visual aspect, and you want it to have sort of a 3D look to it. And in the 101 class, I spent a lot of time showing how to create a hill shade and so forth, and so we're going to sort of repeat some of that here. You can do that for this 250,000 scale data just like you can the 24,000 scale data. It's really no different. So let's do that in this exercise. So hopefully you've already turned on your Spatial Analyst. If not, you'll need to do that. The older version had a nice dialog right up here on the toolbar that you could work with within Spatial Analyst toolbar. Now a lot of times you're easier to go ahead and open the toolbox again because they've added a set of tools for the spatial analyst. And so what we're going to do is use that. Let's expand that, and you got a whole host of toolboxes in there to do lots of different things with. We're interested in this case in the surface tools, so let's expand that. And in our case here specifically, we're interested in the hillshade tool, and that's going to create a sort of a 3D effect of a hillshade. It'd be grayscale, but we'll deal with that in a minute. So let's go ahead and start that tool, and we'll input raster. We're going to use the DEM that we created, which is the only raster we have at the moment, so it's the only option we have. So it makes that nice and easy. We'll use the Clifton, the Cliff DEM, and the output again routes it to your documents folder that you don't want. So let's change that, and let's route that. It remembers the last place we saved a raster data set, which is where I want to put this one, because it's under the mark folder under raster. So I'm just going to leave that like it is, and in this case we're going to call this Cliff Hill. Okay, that's 8 spaces, or I mean 8 characters. So we'll call this Cliff Hill. Save, and it automatically sets an azimuth and an altitude for you. This is the angle of the sun. Basically, if I click in it, the right hand side over here tells me excuse me, that these are the defaults that the program uses, and a lot of times they're just right. I mean, you can tweak these if you want to and play with it and see what kind of results you get. I don't recommend it usually. I like to just keep that default because, like I say, usually it's just fine. For this northern hemisphere, that angle seems to work really well. The Z factor defaults to what is also usually just fine, but it basically is defaulting to a resolution that it is seeing in the data that we're working with. So the program has looked at that 250,000 scale raster, and it has pulled this up as a default. I don't see any reason to change it right now. Let's leave that alone. Again, if we were dealing with really level terrain, it might make a difference. Here we'll just keep that, say OK. So you keep most of your defaults, just change your path. And again, it ran quickly because I've already run this model once, so it ran really quickly, and I got a little dialog that said hillshade in the lower right, but it's on my other monitor, so you can't see it. But once you see the little dialog pop up on the lower right, the little blue dialog that will pop up, then you'll know it's finished. Of course, in this case, it also loads the data set instead of asking you if you want to load it. So it just loads it in there so we can see that it's finished. And there you can see that we've got a nice relief model here, a nice hillshade model. And if you want to zoom in, take a look at that, you can see that our study area in this case is a lot more mountainous over in the western region, which is consistent with what I've seen in the topo maps. So that's nice to know. You can see actually the drainage is in here pretty well. And again, we're looking at a 1 to 250,000 scale. If this were a 1 to 24,000 scale, we would have a lot more detail. But again, initially at least, I'm wanting a DEM model for my entire study area. And I don't want to have to deal with the file sizes that's going to be involved with trying to do that all at the 1 to 24,000 scale, at least not right now. So this is fine for me. It gives me a nice view of the area. Let's see if we can enhance this a little bit. Let's take and let's move our hillshade layer down to the bottom. So basically our DEM model is hiding the hillshade right now, and we're going to fix that in a minute. What we'll do first, let's change the color of the DEM from the monochrome format. Let's change it to a nice one more suited to elevation. What you can do is if you left click on the color ramp. Now you can do this by going to properties and symbology and all of that, but here's a shortcut. Just left click on the color ramp and it pops up with this ramp, and then right click on this color ramp and then say change it from graphic view. See how it's checked by default? I'm going to left click this, and that changes it basically to a textual view. And I did this because I want a specific ramp that's easier for me to pick out by name. Again, let me start this over. Again, left click on the color ramp. I'm having to drag it over to the other monitor here. And then right click on this ramp and then uncheck the graphic view. That sets it to a textual view. Then click the drop down and we want elevation number 1. So I'm going to pick elevation 1, and again you can explore and tweak this to colors of your own liking, but for this example just go ahead and pick these defaults and that will get you through it quicker. Say OK, and it changes it to a pre-designed color palette that's commonly used in elevation profiles. Okay, so we've got our pattern here. We can see the white is the higher elevation, the blue is the lowest elevation, the green in between. You can sort of see the ranges we have. Now let's see if we can get that 3D effect. And what we'll do there is simply set some transparency with this. And the way you can do that is go ahead and left click, then right click and go to Properties on your DEM. And click on the Display tab. And then you'll see transparency here. And let's change this to about, let's change it to about, let's just try 50%. And say, you can either apply or say OK. I'll say OK. And that what that does is that sets the transparency on that layer so that we're actually seeing the DEM or the hillshade below the DEM. Since we drug it to the bottom there, we can actually get the 3D effect that way. Which makes it very nice, and you can even zoom in to sort of see that a little better. Let's zoom into this mountainous area, and again you can see the drainage is coming off. It's makes for a nice profile. Let's thicken up our boundary layer just a little bit so it will stand out a little better, and we can pan around a little bit. Let me zoom out just a little here so we can see a little more of the area. And you can see your terrain now. So I'm gonna go ahead and set this to back to the extent of the boundary layer, and you can play with that a little bit. If 50% seems too much, you can go in there and bump that down to 40%. Usually anywhere from 40 to 55% in that range somewhere is what you'll want. I like that a little better, especially from a distance view. Because realize, what you're creating here is something that you might want to use for visual effect, as well as later we'll use it for more practical things like deriving elevation, contours, things like that if we need to. But in this example, I might just want a nice visual model of my boundary, of my study area. And so I think this looks pretty good. I could snag this, or I could save it out, somehow image capture this, put it in my PowerPoint, put it in your report or whatever. You've got your mins and maxes here on elevation, and because we saved this as an integer, something else that I can do, I'm going to save, by the way, just so I don't have any problems here. Something else I can do, and I think you've had enough of the exercises now, you should be able to do this without any problem, is you can go in there and go to the attribute table, and you can add a column to this table and calculate, transfer the meters into feet if you like. And so I can actually add a column to this. Now this is somewhere, we're going to add this column, but just realize that the display here is using the values that it was created with. So this is part of the reason we created this as integers, so we can do these kinds of things. But you'll want to be careful to not do too much with this. It's kind of hard to explain, but the program is still using what it was created with to do the displays. So we don't want to change too much here, but it's not going to hurt to go ahead and add another column here and get some more information. So let's, just as an example here, I'm just going to do this, and I'm going to just call it feet. Okay, and we'll just leave this to integer, so it will round it off to the nearest foot, and we'll say OK, or we're going to round it to the nearest foot rather. And then what we can do is I'm going to click on this column, I'm going to right click, go to field calculator, and what I want to do is a conversion. We know that there are about, I think it's about 3.28 feet in 1 meter. Okay, so we're going to take those the value field, which is in meters, and you can see our field calculator is starting our calculation for us. It's saying feet equals, so I'm going to go ahead and double click value, adds that to that, and I've here my arithmetic operators that I can use. I'm going to use the multiply, and then I'm going to put a space, and I'm going to 3.28. So I'm going to multiply every cell in there that is at in meters. I'm going to multiply that by 3.28 to get our feet. If I say OK, then it will calculate the records pretty quickly, because again we only have less than 2,000, and you can see it converted that for me into feet. And so that was nice. We've got some more information there to work with, and I'm doing this because I might want to put this in a layout, and I might not want the meters in my layout. I might want to use feet and have that sort of automatically put in there for me using the tools that you've seen in some of the other exercises about how you can put this legend in your layout, for example. So one of the things I can do, and this is a little, hopefully this will work. Again, you got to be a little bit careful when you're actually changing the display values here, because it wants to use meters there. We're going to try this on the fly and see if this works. And I'm going to actually, I'm going to leave this like it is, because I was going to go ahead and try to change this on the legend for you into feet, but I think I'm going to leave it like it is, because just from past experience I've run into some issues doing this. So for now, for this exercise, I don't want to cause anything that's going to create more headaches than what we need. So let's just leave this like it is. We have that value in there, and that can be valuable to us later, and some things we can do with this. So it's okay to go ahead and create that like we did, but let's just leave our display for now like it is, so we don't cause any problems with the program. So we'll leave it like it is. You know how to add fields to it though for your table, and again we can use those later. We've got our model, which is what we set out to do. Hopefully you can now do this with your area, get a nice DEM model for your area. Let's save our work, and we'll go ahead and stop with this exercise, and I'll show you some things later that we can do with these DEM models beyond this. But hopefully this is a valuable addition though, to at least get you started with some of the visual elements of it. Realize that we can lay other information on this, and it looks pretty good. Like for example, if I had streams, which you can get streams, I could lay those streams on here, and it would sort of verify what we know, what we can see visually here, where these drainages are. At least we think. Well, if I lay the streams on it, then you can actually confirm that, and it actually enhances your view quite a bit. You can label those streams, for example, and you can end up making a pretty nice DEM map with roads and streams and things like that laid right over top of this. So go ahead and experiment with some of that. We'll stop this for now. We'll do some other things with it later, and hopefully you found this helpful.